Hi, and welcome back to this is episode 3 now in our design series, where we're kind of going step by step through the Onshape software and explaining how to design, I guess, a mountain bike. In particular, on this example, we've picked an orange stage 6. So if you haven't seen the first two episodes, I would suggest that you kind of circle back. I'll put the links below, and learn how to piece together your geometry skeleton, and then also how to design or sketch a suspension layout. All that stuff's covered in there. Configurations as well. So you'll see in this sketch we've obviously got different sizes and we've got different suspension settings. So all of that was covered in episodes 1 and 2. So yeah, like I say, the link will be below if you haven't seen those. But in today's episode, we're going to go from a geometry sketch to a sort of finished front triangle, and we're going to go step by step through most of the key kind of solid modeling features that Onshape has, and try and sort of explain the best application for each. And this front triangle is quite good. It's sort of there's an example of each of the different features there. So first things first, we'll skip out and we'll start into this demo part studio. So again, this is pretty much where we left off at the end of the second video. So we had our kind of imported photograph of the bike. We had our geometry that we pulled from the manufacturer's website, and then we had a kind of rough suspension layout there, which worked in configurations. So the first thing we're going to do is start part modeling today. This is an aluminium front triangle, so it's lots of different tubes obviously then that are welded together. So we're going to model them as individual tubes. We're going to do this all within one part studio. Now Onshape has that power and that ability to let you do that, unlike some other software packages. However, it's fine for a small kind of assembly of 5 or 6 tubes. If you were designing something that was over 50 pieces or parts, you may want to do it differently. And again, we'll show you probably the correct way, or the way that we prefer to do that, in a later video. But for the purposes of this front triangle, for this orange stage 6, a single part studio is fine. It does get complicated later on, but we'll get to that when we get to it, I guess. Okay, so the first thing we're going to start with is the bottom bracket shell. So this one's really simple. We're going to use the extrude feature. So first of all, we need to start a sketch. Our orientation, these are all hidden at the minute, but you'll see the right plane is the kind of center line of the bike. So we're going to start with that, a sketch on the right plane. And very simply, bottom bracket shell is just a circle. We'll make it 44 millimeters. And we're just going to extrude it as a solid. So we accept that sketch, and it's good practice. It's a bit tedious, but it's good practice to rename the sketches as you go. So we'll call it BB sketch. You can call it whatever you want. So this is the extrude feature on Onshape. So click on that. You'll see, are you extruding a solid or a surface? We're going for a solid. And then you've got 4 options below. Really, the new, add, and remove are the most popular. Intersect's useful at times, but it's kind of hard to explain. We're going to start with a new part. So we're going to select this face. So you can either select it here in the window, or you can actually select the sketch and it'll put everything. That selecting the sketch does get complicated if you've got lots of different lines in there, but for the purposes of this, it's fine. So you can either drag it out like this, or you can put a specific value on it. What we want to do is click symmetry, because we want it to go obviously left and right of the center line, and we're going to say it's a 73 millimeters wide BB shell. That's all good. Hit the tick. Now again, good practice for this, we'll call it BB extrude. The only reason I'm naming these is so that you can reference back later as well, because we're not going to use extrude for each one of these tubes. We're going to use different features, so it's kind of good as a reference. Now you'll see the first part that we've got again is there. Let's rename that and call it BB, or BB shell. You could continue modeling now and put the threads and the bore and stuff in there. We're not going to do that in this example, but you would follow the same principles. Again, you would start another sketch on the same plane, and you would extrude and remove the material, which you saw there. So instead of new or add, you would hit remove, and that would essentially cut away what you didn't need. So that's the BB. The next sketch we're going to do is the seat tube. So we're going to start a sketch. You've got a couple of choices. You can either create a plane somewhere to draw that seat tube sketch from, or what I find is quite useful, is a mate connector. So click on the mate connector icon. We are going to want to start here where the seat tube ends. So essentially, that's not going to work for us. Okay, not ideal. We'll start at the bottom. So click on this line. You can see this mate connector that comes up at the very bottom, and it's aligned with the seat tube. That's the one we want. So click on that, and it's going to allow us, essentially you can see this plane that's being created. So it just takes one step out of the process. So we've got that. Now we're going to draw again a circle from the origin, and we're going to make that seat tube size, so 34.9 millimeters. We're also going to draw another circle, and we're going to make that 31.6 millimeters, which is your seat post size. So now we're doing, rather than extruding a solid like the BB shell was, we're going to extrude a physical tube. So that's all good. So we can hit the tick and go, or what we can just, if you want to cut out some steps, you can just jump straight into extrude. Now you can see it's trying to go the other way, so we'll flick orientation around. We could, if we knew the length, just dictate the length, but at this point we're going to use a neat feature which is called up to vertex. So instead of dictating the length, we're going to say it's going to go up to vertex, and it's going to go up to this point, which we plugged into our geometry chart at a much earlier time. So before we hit tick and accept all that, it looks good, but what it's trying to do now is add rather than create a new part. So this seat tube, if we accept now, what will happen is actually you'll end up with still one part, and the BB and the seat tube will be joined. Now, yes, they will be joined in the real world, but they'll still be two separate parts, and they'll be welded and then essentially become one front triangle, but that's not what we want. So we're going to go back in, edit that, and we're just going to select new. And so now you'll see we've got the bottom bracket, and we've got a second part, which we're going to rename as our seat tube. And again, we'll go back in and rename our sketches. So that is seat tube sketch and seat tube extrude. Okay. Next item we're going to do is the head tube, and we're going to actually, you could do this the same way. You could have some sketches and you could extrude it, but for the purposes of showing you how some of the other features work, we're gonna revolve this head tube, which can be useful too, because not all head tubes are just straight. They might have some profiles and some different bearing seat dimensions, so it's quite useful to revolve it. So we'll start a sketch. We're going to revolve around this axis, so we'll start on the right plane, and this becomes the axis that we're going to work towards. Or work around. So we're going to start with some construction lines just to make this kind of straightforward. We're going to set this line off here. It's perpendicular with this center line, so it's a good start. This is going to be our internal face, and again, this, if we just shoot this line off into nowhere, what we can do in terms of constraints is click this line and this line, and they'll be parallel. And I'll put some dimensions on later on. So what we want to do again to make sure, instead of putting dimensions in here, so again we can click on this line and see that 110 millimeters is the head tube length for a size large, but we put a lot of effort into, first of all, getting our geometry correct at the start, having a really good geometry sketch, and then also configuring it so that the sizes do change. So we don't want to put in any dimensions in here that might override that or cause conflicting information. So what we want to try and use is work with what we've got and work with the configured geometry that we have. So I'm going to put this center line in, make it perpendicular with this, and that's essentially determining the length of our head tube. So as we flick through our configurations, those will change automatically. We don't have to, you can see there now it's 120 millimeters. Flick back to size large and it changes to 110. So yeah, there's no dimension on there. So that's something to bear in mind. Okay, we're going to want to give it some thickness. So again, draw a line out here, another line right here. Both need to be parallel with the this top line, and we're going to draw that in there. We're going to want to put a dimension on these, and that's fine. So we're going to want to say 3 millimeters wall thickness. And again, this is your inside face where your headset cup will sit, and this will be just an outside face of the aluminium head tube. So we'll make them both 3 millimeters. Rather, what you can do is useful is click them both and just hit the equals sign, and that means they're both exactly the same. So we can see it's not fully defined yet. We can still move it in and out. and both are blue because they're both movable into two different positions. But I think what we need that's critical now is this internal dimension. So this is going to be half of what a headset cup would be. So for example, it might be 49 millimeters. And you can put it in as a formula, so it could be 49 divided by 2, and it kind of takes the guesswork out. Okay, so it might not look like much right now, but when we go to turn it into a solid, you've got your revolve feature. We don't want it to be a surface, we want it to be a solid. It's going to be new. Select the items that you want to revolve. That's this area, and again you'll see it highlighted, and then the axis is here. So straight away we can have a check. Yeah, that looks like a head tube, looks correct. We want it to be a full revolve. We don't want to just have a partial, you know, that can be useful in some scenarios, but we just want a full head tube. So again, accept that. So we can see things starting to piece together now. Let's rename this part as head tube, and again we will call this the head tube revolve sketch, and this is head tube revolve. Okay, let me just check what the next tube we should do. C tube, head tube, revolve. Yeah, well, let's tackle the down tube next. So something we didn't do at the start that we could have done or possibly should have done is a bit of a tube layout sketch. So we'll turn on the overview of the bike for this example. Obviously, if you were designing your own bike, you wouldn't have an image. You would just have to decide where it's going to go based off clearances and aesthetics and all that. So you would be deciding. But for the purposes of this example, we're going to put a tube layout sketch, and essentially that's going to be the center lines of the sketches, or the center lines of the tubes. For example, now with most orange bikes, obviously it's made from kind of folded sheet aluminium, so they've got some quite complex shapes. For the purposes of this, we're going to just simplify those in some respects. Obviously, once you're comfortable with modeling and you understand the core principles of what we're talking about today, then actually you can go and, you know, elaborate and make the tube shapes a little more accurate to real life. And if you do that, we'd love to see your examples. So do send those through. So we're going to start again a sketch on the right plane. We've already got the critical geometry, so everything needs to kind of fit that geometry sketch that we've got. And again, it's quite subtle. It's maybe hard to see, but the down tube and the top tube and this little brace all have a gentle curve. So we're going to select spline as a tool. We're going to roughly find the center line of where this top tube joins the seat tube. It's roughly there. And again, we're going to try and find roughly where this top tube would join the head tube, which looks to be roughly somewhere here. Okay, because this is a spline, we can kind of control it, which is useful. So again, we'll try and just move these little toggles to get it roughly centered with that. Again, for the purposes of this, it doesn't need to be super accurate, but if it's your own bike and you've got real kind of parametric parameters to work with, then you'll want to obviously try and keep that as accurate as possible. So that's top tube. What is kind of good practice and might be useful later on, you saw the issue we had with the mate connector in the seat tube. So good practice, I would always put a kind of construction line here at the end of this, and make it tangent with the spline. And the reason for that, just it gives you a little bit of material to use in terms of putting your mate connectors on. So it's useful. So again, just make sure that you click on the spline, not the toggle, and make that tangent, and then we can readjust the position slightly. There we go. I'm going to actually delete that and start again because I think it's done something a bit funky. Because we haven't dimensioned, maybe we should dimension these lines actually. So let's stick a dimension on here. 36 sounds good. Lower that back to where it was. And yeah, if we don't have enough constraints, then things do start to move around a little bit. So, okay, that looks pretty good for now. We'll stick another curve in. These can all be in the same sketch because they're really just a guide. So we're going to start. Down tube looks like it starts roughly down here where the BB is, and if we were to follow this straight line, it looks like it kind of goes to pretty much where the top tube joins. So let's go with that as an example. We'll give it a slight bow up here, and that looks pretty good. So we don't really need to do too much more on that down tube from where we are. And the only other one is this brace. So again, it's like the spline. Try and find, follow roughly where you think the center line would be. Same story here, and then just add a little bit of curve so that it sits roughly where you think the center line might be. And we will stick a dimension on this so it doesn't move. 30 millimeters sounds good. And then we'll do the same thing and put our construction line here and make it tangent with that line so that we've got it there for later. We shouldn't need one here at this side. I don't think. May regret that. We may come back. Okay, so let's give this a name, and we're going to call it the side profile centerline sketch, if I can spell. Okay, and we'll drag it up. This is kind of useful. You know, we'll drag it up the tree so it sits up here. And again, there's no errors. It's not related to any of this other stuff. You'll see here I've created some folders at the start. This is more of a guide just to keep me on track when I'm going through this kind of series. I've already modeled this whole thing out once just as a test bed to make sure I covered all the right subjects. So all of this stuff will get moved into the appropriate folders once it's done. Okay, so we're nearly ready to model our tubes. Down tube, we're going to do it as a loft. And in fact, that's part of what I wanted to do to cover all of the features today was do lofts and then guided lofts. So actually I'm going to change that line, which is virtually straight anyway, and we'll just make that a straight line. Okay, for simplicity purposes. So we needed a sketch of down tube. It's joining a couple of things together. So it's joining a head tube, which is 55 millimeters external width, so we know it needs to be less than 55 millimeters, and it's a 73 mil shell, so that's fine. So what we're going to do is start with the loft feature. Basically joins two different sketches or multiple different sketches together. So we're going to have a sketch at the start and a sketch at the end of the tube. So let's start with that. Again, click on Make Connector, select the tube or the sketch of the down tube. This is where it gets a little bit complicated. That's the one we want as you develop multiple parts in one part studio, because the other parts that you've already drawn or modeled actually start to cause you some grief and get in the way. So okay, where you want, let's say, I mean, this is not exact, obviously, based off what orange bikes do, but let's start with a square or rectangle, and we'll round the edges. So in terms of height, we're going to want to see roughly where we think that might be. Let's have a guess and at maybe 50 millimeters. Actually, we can base it off this, which is 44. Let's do that. So then we're not going to have any major overlap on our bottom bracket. And the width is, again, let's have a guess at 50 millimeters. Okay. So we could just extrude or loft this sketch, and it would basically be the same shape here as it is up here where it ends, but that's not what we want. That's just a normal extrude. So we're going to want to create a different profile up here, and essentially what the loft feature does is allows that to morph and transform from a square into a rectangle, whatever shape we put up there. But just to keep things a little bit more aesthetically pleasing, we'll put a couple of rads on the end here. So radius, we're going to say 7.5 on there. Okay, so that's our first sketch. We can't really do anything with it right now. Well, we could extrude it, like we said, and you'd end up with a very boxy looking tube. But that's not what Orange use. So to finish our loft, we're going to have another sketch. Click on Make Connector, and we're going to select this line, and you can see the Make Connector flags up here. So it's created our plane. You could draw planes and do all that, but you end up with hundreds of planes in your sketch that get really confusing and misleading. So I tend not to do that. So again, we'll do a rectangle this time. So not a massive change, but we'll go up here and we'll say it's going to be 50 millimeters wide, and it's going to be, yeah, let's say 70 millimeters tall. Okay, so that still falls within the head tube. That's all fine. And we'll add our little radiuses on again here. You could have a bigger or a smaller radius than you had at the bottom if you wanted to. Like the loft feature is quite a powerful tool, so it will figure that all out for you. But for the purposes of this, we'll keep it the same. So we've now got two sketches. We've got our down tube rear sketch, and we've got our down tube forward sketch. Okay, so this is how the Loft tool works. You select it here, Loft. Again, we want to make sure we're on solid and not surface. And if you can find the part here or your sketch, you can click on it, but if not, you can just click on this one here. Some of the tools in here require you to select a different box before you pick the end one, but with Loft you don't, because you can select multiple. You know, you could have another midpoint sketch here if you wanted and click that, and the Loft feature would the Loft command would figure that all out as it goes. But we're going to sketch on click on the first one and click on the last one, and yeah, essentially what you get is a very straightforward, simple Loft. It's a solid, it's a new part, all of this makes sense, so we're just going to accept that. And if we turn off the sketch in the background, yeah, you can sort of see the profile that you've got. So it's starting off very square here, and it's moving into a taller kind of rectangle shape here. Okay, it's very box section, obviously, but this is just for an example. But you could spend as much time as you want, you know, refining these sketches and make it, you know, that could be round, square, oval, whatever shape you wanna do. So okay, so that's our down tube. So we're gonna give that a name as a part. So far we've got 4 parts in this part studio. It's starting to fill up, and you can already see it starts to get slightly complicated as you work through your features. They're all different colors, they're all different parts. That's what we want. We don't want anything to be merged with any other parts just yet. But like I say, simple part studios, 5 or 6 pieces, no problem to do it here. But there is a way, and we'll show you that in a more advanced video later on, where you can design parts in their own dedicated part studio. So that down tube might have its own part studio, the head tube might have its own part studio, which is super useful. Okay, so we've done the down tube. Next thing we're going to do is the top tube. We're going to loft it again, but what we're going to use is a bit of a guide or a path, which is this curved spline as well. So we follow the same principles. We'll have a starting sketch, and this is where this little construction line comes in. It makes it really easy to pick the starting point here, and make sure that it's kind of tangent with the spline curve. So similar story, we're going to pick a square shape here, stick some dimensions on of let's say 34 millimeters, and we'll do 34 and 34, that makes sense. And we'll put some little radiuses on again just to tidy it up. Anyone that's bashed their knee off the top tube of a bike with sharp edges knows the sheer agony that can happen. Okay, so that's dealt with. That's top tube. Well, and again, it's always good. It's a bit laborious, but it's worth naming as you go, because if you ever need to make a change, sometimes you can get lost in just sketch 1, 2, 3, 4, 5. It's nice if they've got a name. So we'll call it top tube rear sketch. And again, next thing is click on if you can never find, if you're trying to find that mate connector and it doesn't come up, it's because you haven't selected this. So make sure you click on that, and then they should pop up. So that's what we want there. And we're going to do a similar kind of theory to what we did on the down tube loft. So we'll have a kind of slightly taller rectangle shape. So we'll maybe make it a little bit wider. I think it started at 34, so let's make it 44, so it's a bit wider, and we'll make it a bit taller as well. 44 sounds good. And we'll put some edges on there. We'll keep those at 5 millimeters. And if you need to, you can toggle the picture on and off just to see, you can kind of see that tube shape starts smaller and then gets, larger in volume as it gets closer to the head tube, which is normal for most bike design anyway. So, you're on the right path. So everything looks good. We'll accept that sketch. Again, we'll give it a name. Sketch, and we're going to go into loft. So a bit like we did with the down tube, we'll select our 2 sketches. Yeah, that's all fine, but you can see straight away they're just going very much straight point to point there, and this spline in the middle is that's the path that we want it to sort of take. So what we do is go down, guides are useful, but they are more like the outer edges. So at top and bottom, if you had those sketches there, you could use guides, but I find that if you're working off a center line, which is a bit more simple, just select path and you select this curve, and you can see straight away that it kind of gives it that curve that we saw in the initial sketch or image import that's here. You can increase connectors, but for simple shape, that just adds more sections, helps you kind of understand the transition and smooths out the transition. But we don't really need that on a simple top tube design like this. So hit accept. We've got another part. It's all worked the way it should have. So we'll give it a name. Top tube. Yeah, okay. So that we've covered kind of extrude, we've covered loft. You could do these with a sweep feature as well, but what you would end up with is you'd have the same curve that we used the spline to produce, but you would end up with the same start and end sketch. So if this rectangle at the rear, if we swept that, it would just be exactly the same when it gets to here, which is not what we want. We want it to increase in size as it gets closer to that head tube. So that's what we've got now. So last piece is the brace. So we're going to put that in there, and again, pretty much following the same principles. I'm just looking at the older version that it did. Actually, I think we could use guide curves for this. Yeah, well, let's do that, and then that might make life a little bit easier. So we'll start a new sketch again on the right plane, and instead of using this center line to just loft, we'll put some new splines in there. So first thing we'll do is we'll create our start and end sketch first, and then we're going to dictate the path that they go down. So we'll put our sketch in here on this part. See it here, and let's start with again square shape. There's a theme here, and I think it's quite a small. Let's say 20 by 20, because in the image that we brought in, it's quite a small profile. So yeah, like I say, you can always toggle it on and off and see. Yeah, it looks maybe even smaller. Maybe it's as small as maybe 16. Okay, and don't forget, we'll round those corners because it's a smaller size. We'll maybe drop the rad to 2.5. And yeah, finishing just like we did. Okay, it's not going to work there, so we're gonna need to go back in and add a construction line to this one as well. So just put that out there in space and make it tangent with that line. Yep. Go back in, try and recreate our sketch, and only this time we can select that plane much more easily. Okay, square, and we'll make this 30, for example. This 30 looks kind of roughly, maybe a little bit big. Let's make it 26. And round the corners. Well, maybe this time we'll put a bigger radius on those corners, and you'll see that transition. Okay, so we could just loft with the center line if we wanted to, but for example, we maybe we want a slightly different curve on the top than we do on the bottom, or we lose control. If you're relying on the center line, really you are only determining the path of where the loft's gonna go. You may decide that you want it to start thinner and stay thinner for longer, and you can't really control that as easily. So what we do then is we use guide curves. So we'll go into this right hand sketch, align it to the right plane, and again try and use the splines, and this time what we're going to want to do is have it sit on this line. So it's not going to let us select it first, so let's just put a spline in here somewhere. Just check there are no constraints on that. So you can highlight this top line, this point. We're going to make those coincident. And we're going to do the same here. Okay, and now we can start to really control how these start and end. So we're going to want to bring that down. You can sort of see the overlay in the background. Toggle those, and then we're going to want to do the same again on the bottom. So put another spline in here, and then we're going to make it coincident with those. Okay, and now you can see how much control you've got, where you could, you could put a waist in it if you wanted to in the middle, but it doesn't look like that's what Orange have done, so we'll try and replicate what they've done, and that looks kind of similar. So yeah, obviously these are undefined, you could add dimensions and define that, but for what we need, this is okay. So we are going to do a loft now, like we did before. We're going to pick this sketch, and we're going to pick this sketch. You can see straight away they just want to go in a straight line. If we used path and use that, obviously you can kind of see where it goes, but that's not what we want to do. This time we want to use guides, and we're going to use this top sketch that we put in, and also then you can see when I click on this bottom sketch how it's going to tighten in that bottom side slightly, so it gives you a little bit more control. Okay, solid, new, yeah, and again we've got another new part, you see it down here, so we're going to rename that and call it top tube brace. Okay, so we can sort of see, it's hard to see with the picture still on, but we'll turn that off, and you've got what roughly looks like a bit of a mountain bike front triangle here. Obviously there's a few things missing, main pivots and shock mounts and stuff, but we'll get to that in another video obviously. But yeah, essentially you've got what appears to be a front triangle. So that's the majority of your part modeling done. Let's just give these some names. So top tube brace sketch 1 and top tube brace sketch 2, and then we're going to say top tube brace guide curves, and this is our top tube brace loft. Okay, select all this stuff now, and we're just going to tidy it up. So we're going to drag it into the part modeling folder, so we can close that out of the way, and this keeps your tree a bit more a bit less cluttered, I suppose, a bit more tidy. So the next thing we're going to want to do to kind of finish this off is shell the tubes. Now we can go to the section view here. It's always a good kind of check to do. Click on the right plane and you can see, okay, we've got seat tube looks right, head tube looks right, but obviously all these other tubes we've extruded them and lofted them and swept them as a solid, so we're going to want to shell those out. So because we're in one part studio with multiple parts, the easiest thing to do is to right click on the first tube. You can isolate that, and then the shell feature is this one. So you're going to want to, you don't want it just to be a hollow tube, because then it's still got these end caps, so don't select that. You're going to set your wall thickness, say 2mm, and then you're going to select the two faces that you don't want. So obviously we don't want that face and we don't want that face, and accept, and now we've got a tube that's 2mm. It's got a 2mm wall the whole way through. So that's the top tube done, and we just repeat the process. So go back into shell, say 2mm again, and select the faces that we want to be open. There we go. And the last one, shell 2mm, and obviously these are just random wall thicknesses. I wouldn't use these. That. Okay, so that's that done. Our bottom bracket, normally we would, you could use a few different features here. You could just extrude cut a sketch through there, or what you could do is a bit like we did with the head tube. You could revolve a sketch in here to leave you with meat for your threads, and then maybe a bit of a waist in the middle to get weight removed. A whole stack of different ways you could do that. But we'll go back into our section view again. Right plane, you can see is still selected, and all of a sudden you can see that we've got hollow tubes. Everything looks correct. Now obviously, apart from these tubes are crashing into each other, see all these red spots where there's an interference, so we want to fix that. So now that we've done our shells, we'll select those, we'll drag those into that folder, and the only thing we've got left to do now is to miter these tubes. Now, because we've designed everything in a part studio, it's a bit easier. We can just use each part to remove material from the other one. So a couple of different ways you would do it. The easiest way, so let's take the down tube and the head tube, for example. We're going to want to cut all of this stuff out of here so that you can see straight through the head tube. So easiest thing to do is use the split feature. So we're going to split, what are we splitting? It's this tube. We're going to split the down tube, and we're going to split it with the head tube, and we want to make sure we select the right surface. So it's this outside surface. Make sure you don't select the inside one, because that would do the same job, but it would cut just the stuff you can see on the inside, whereas actually the stuff that's the part of the down tube that's traveling through this head tube we want rid of as well. So we click that. Make sure we keep the tools, because the tool now, your head tube has become the tool with which you're cutting. So if you didn't select that, your head tube would disappear, which you don't want to do. So we accept that, and we're going to do this. Yeah, we're going to delete that part now. So essentially, when you look at your parts list, you've got two down tubes. You've got this down tube, and now you've also got this other part. Because they were both named down tube, they're both technically under the same name, but you've got two different versions, one of which we don't want. So we just hit, this is delete part, we just select on the part we don't want, and we can see it's disappeared. So obviously the top tube's still in there, but okay, next thing we want to do is trim the top tube. So we just repeat the process. So we're going to split this top tube. This time it doesn't even reach the head tube with whatever way we've laid these sketches out. So we're going to use the we're going to split it with the down tube. So select down tube. Oh, it's not going to want to use that face. It's going to want to use this face. I don't think you can select multiple faces. No. Okay, so this is a good example. If we just use this face, essentially it will split it, but it won't match the radius, if that makes sense. So I'll do that, and you'll see, you can sort of see the split line. So imagine someone's taken a knife and just run it down here. That's the split that you've been left with. Because this is going to be welded, that's actually not the end of the world. It works out quite well. If this was an issue and you really needed a nice tight fit, say around that head tube, for example, you would have to create a surface, which you can do using surface offset here. So you would set that to 0. And what you would end up with there is a surface, and you can use a surface to split, and because that's all one surface rather than just a face. So if we undo that split and try and repeat the process, so we're going to split the top tube, but instead of selecting that part of that, you can see that the surface now highlights and then disappears afterwards. That's all fine. So now the split follows this contour rather than just the flat plane, which is a bit more useful. So we're gonna hide our down tube because it's kind of getting in the way. So yeah, you can see the part that we now no longer want of the top tube. So again, we just go in, click on that, and delete, and you can see that slightly you can see where that radius was now on that split. So it's kind of a good tip to know. Okay, that's that dealt with. I'm just going to really quickly rattle through and tidy the rest of these up as well. So split that. Oh. And we're going to split with the seat tube. Delete these parts. We don't want that one. If we hide our top tube, we can delete that part as well. Okay, that's that dealt with. And we need to split our down tube with the bottom bracket now. So select down tube. I'm going to split it with the BB. We're going to hide the bottom bracket so we can delete the part which is in there. And then the seat tube needs to be split in a couple of places. It needs to be mitered to fit onto the BB, but it also needs, I mean, you personal preference, I suppose. You could miter the down tube to make space for the seat tube to go in. That probably would be an easier thing to do because you just need an end mill the same, or a super big massive drill bit the same size as your seat tube. So let's click down tube, and we're going to split it with the seat tube if my mouse would work. Okay, hide the seat tube, and then we can see the part. So we're actually left with multiple parts of the down tube, so you might find that there's a bit underneath, yep, that needs to be split as well. So we'll take that away, and you can see now that's how obviously the seat tube would go in there and miter. So we can just finish off by mitering the seat tube with the BB. Take that out, delete that last part. It's a bit tedious, and a bit of practice, it kind of comes quite naturally to you once you've kind of put a bit of time into it. Okay, so final check would be go back into our section view, right plane still selected, and we can now see Oh, we missed one. We missed the, yeah. So it's worth doing these checks because you'll see if you've forgotten one. So we forgot to split the top tube. Let's split that top tube with the seat tube. We might even be able to see down in and delete the part. Yeah, that's it. Okay, so that's us done. We've got an assembly of 1, 2, 3, 4, 5, 6 parts, 6 tubes. They are all just parts. They're all individual. They're not joined together, so it's not one part. What you could do is bring those into an assembly and mate them in place or fix them in place. We'll cover that in possibly the next video, where we're going to cover assemblies and exactly that, mate versus fixing and all that kind of stuff. And off the back of that, in episode 5, we'll cover in-context modeling, which I touched on at the start, is a better way of designing parts in their own part studio, but in relation to an assembly that has other geometry in there. So this is a really simple way. It's great for if you're doing a hardtail or rigid frame or gravel bike frame, or a simple front triangle like this. If you were starting to do the rear triangle and model that all in one part studio, things would get busy, complicated. You also end up with a really, really long kind of design tree, which isn't great for processing power and all that stuff. Because this software is cloud-based, it kind of starts to struggle once you've got multiple parts and multiple different features. So we'll hide all these in the miter folder. Good housekeeping. And then I guess the only other thing to finish is we've got lots of different parts in different colors. If you want to change the color or material of your part, so you can get a rough target weight or any of that stuff, you can assign a material in here. And the same with an appearance. So if you want to make every tube orange, for example, you can just go in and select. Once you're in this window, you can just select all of the tubes as well. Yeah, there we go. So now you've got a fixed kind of color scheme for one part, and it can be whatever it needs to be. So that's pretty much it for this episode. Like I say, we have a couple more episodes to come where we'll tackle a little bit more in depth. Each one will build up and kind of cover more complicated stuff, but hopefully that helps with a bit of a grasp on how to start kind of basic part modeling. And yeah, kind of from that point forward, the world is your oyster. You can spend as much time or as little time designing and developing parts in there. But show me your examples. If you get stuck, send us questions either in the comments on YouTube or reach out on social media. And yeah, I'd look. Hopefully this has been some sort of help to somebody. Okay, catch you in the next one. Thanks.